Hello, this is Kaushik again. Today I'm going to cover a very popular unsupervised machine learning technique. As you can see in the screen, recommendation engine with Apriori algorithm. Before proceeding further, I would like to mention I'm going to cover the concepts behind a recommendation engine first, then proceed to the algorithm. As you can see, I have opened the tab over here already. And so those who are already clear with the concepts can fast forward to the algorithm part. So let's start. So let's first understand what is a priori algorithm. So suppose you have a offline or an online business and you want to increase your upselling and cross selling. So this algorithm is your best friend, and you want to check from your data set of thousands of transactions. You want to find a relation between products, like which what are the set of products which are frequently purchased. For example, milk and bread, or for example, meat and spices. So you see that people who are buying meat are also likely to buy spice, right? So definitely, if you have a super shop, you would like to keep spice section behind meat section. So that's a very normal, very understandable recommending. But sometimes we find out very unique relation between two products. Like there was this one case in one of the state in USA where it was found that men who buys beer are men who buys baby napkins are also likely to buy beer as well. So this is a very unique relation which was discovered through this algorithm, right? So okay, let's proceed forward. Okay, so suppose we have 8 unique transactions. So as you can see, apple, beer, rice, chicken, and you want to find association rules, right? So what do you understand by association rule? uh, to understand association rule, we have to understand three important metric: support, confidence, and lift. So let's first understand what is support. So support is nothing, it's basically the items which are frequently purchased divided by total number of transaction. So it can be, for example, support of apple is 4 divided by 8. So number of total transaction is 8, and how many times apple was purchased? 4 times. You can find support of multiple product as well. For example, apple and beer, how many times? So the support of apple and beer. So you see apple beer 3 times. Apple and beer were bought together. So divide by number of transactions. So here 3 by 8. So uh, now we have to find the confidence. So okay, so before explaining that, so what we understand by support is how frequently item or items are purchased. So what is confidence? So how likely product B is purchased when product A is also purchased. So here in our case, how likely beer is purchased when apple is purchased too. Apple is purchased in the beginning. So, I mean, given Apple is purchased, how likely beer will be purchased? So, support for Apple and beer, we know, 3 by 8, and divide by support of Apple. So, here we are finding the confidence value 0.75. Now, after finding these two metrics, support and confidence, so you might come up with a question that beer is a very common product. So it can be purchased with any other products as well. So how come we can how do we come to a conclusion that it is always purchased when Apple is purchased? Definitely, this is a very reasonable question. So that's why we want to find out the metric lift. So that we can control the popularity of one product. For example, beer is really popular, so we can in US obviously. So we cannot come to a conclusion that it is purchased. It has a strong relation with purchase of Apple or any other product. So to understand that, this is the calculation. So we first find out the support of Apple and beer, then divide by support of Apple and support of beer. The definition is here. I've written how likely. So what do you understand by lift? How likely beer would be purchased when Apple is purchased while while controlling for how popular beer is. So for example, let's forget about beer. Mineral water, definitely, you can see in any water might be purchased with any item. We cannot say that a particular product, if we buy, there's a high likelihood that water will be bought with this. This does not make sense. So what we understand by this, if we control for the popularity of water, so that means if we see, if there is no relation, so how do we understand whether there is a relation with that particular item with the item which is purchased. So if that is, we can understand by the score of lift. For example, if we have lift score less than 1, we come to a conclusion that there is no relation. For example, if the lift was less than 1, we would say that there is we cannot come to a conclusion that beer is likely to be purchased given apple is purchased. But if we had lift more than 1, we can say yes, when apple is purchased, it is highly like it's most likely beer will also be purchased. But if we have lift score 1, it means the purchase of beer is completely independent. It has no relation to the purchase of apple or any other product. So I hope I could explain the conceptual part. uh, let's without much further ado, let's proceed towards the algorithm part. Okay, so we start with all the relevant libraries, pandas for data set manipulation and numpy for mathematical operation. So we also use transaction encoder. This is because we want to transform this string values of the data set to Boolean arrays. And obviously we will need a priori and association rules library to build our recommendation engine. So we have loaded the data set. I have loaded the data set and let's see first. So we have to consider each transaction as a each unique basket. For example, in the first basket, a person has bought shrimp, almonds, avocado, vegetable mix, and so on. In the second, burgers, meatballs, eggs, and there are about 7,501 transactions, and this 20 it's not 20. We have the maximum amount of items bought in a basket is 20. It's not that 20 unique items, but the maximum amount of uh, items which was purchased. So let's move forward to the data exploration part. So we want to find out the transaction, for example, top 10 products, which are top 10 mostly purchased, most frequently purchased products. So for that, some basic for loop we have used, as you can see. And we also want to count number as you are measuring frequency of how frequently the products are purchased, and we want to sort by the number incident counts. So we see that mineral water is most purchased, then comes eggs, then spaghetti, and so on. So we also want to see the least purchases given the data set. So we see napkins, water spray, asparagus, yes. So the length of the table is 120. Okay. So let's further move for the let's move forward to the further data processing. So now let's first convert the data set into NumPy array. And because why we want to convert this string values to booleans, as you can see through transaction encoder library. So now we have all the items as booleans, and here in this columns now we have all the unique columns. So previously when we saw these 20 items here, so these were the maximum amount in a basket which were purchased, but now we have all the unique columns here, unique items bought, and we find that total 121 unique items purchased so far, given the data set. And let's also check the let's only we're going to consider top 50 items for the convenience. So we're going to only consider we're going to take only the top 50 items here. And this is the code for it. Okay, so now we have to convert we have to encode. It's one hot encoding. We have to convert the Boolean items to integer items. So for a very simple function to for one hot encoding, and this is here you go. And finally, the algorithm implementation. See this a priori algorithm we see. So here minimum support we have kept 0.1. So you see it's a data set of 7,500 about, right? So we want to find at least we have to find all those products which has at least support value of 1%. So after that we are also considering in each basket, as I said before, each transaction will be considered as each basket. So we want to also find out length of each basket, so and also their support value. So I've explained what support means. If you remember, in the beginning of video I've explained. So here you see that support value for mineral water, eggs, it's supposed to be quite high, as we have seen before that they are the most purchased item. And we also see a basket with multiple products: ground beef, mineral water, chocolate. Okay, see three length of basket is 3, and we have 1.09% of support. Let's check basket which has length of 2, which means we have 2 items and support at least 4%. So yeah, here you go. This is the code. Let's also check for baskets which has about 3 items. All right, so let's move forward, and now finally let's find out the most important part, the lift metric, and very important one-line code. And with this we can also find our support and confidence value as well. We don't have to separately calculate confidence, because after applying association rule library, and if with very simple code, and we're gonna find all the important metrics here. So one important thing, antecedent and consequent. So what we understand by antecedent and consequent: so antecedent is the product A, and consequent is product B. For example, if we buy, for example, let me explain this part. If we buy mineral water, high chances that we'll buy spaghetti. Or another thing, if we buy spaghetti, there's a high chance we're gonna buy mineral water. So antecedent is the first product, and consequent is the next product. The chances of buying the next product given this product A is purchased. So let me explain it again. So given product A is purchased, antecedent, product B will be purchased, which is consequent. So which is the consequence of purchase of product A. I hope I could explain that. So yeah, we're giving minimum threshold of 1.2 here. One important thing to notice for lift, because as I have mentioned, for the lift value, if lift is less than 1, that means we can totally understand that there is no relation between two products. And if the threshold is 1, which means the item is completely independent, no relation at all. So obviously we'd want to find those products which has lift score more than 1, so that we can understand that yes, purchase of one product is causing purchase of is actually the people who purchases product A are high likely to purchase product B. So in this kind of conclusion, if you want to come, so we're taking at least minimum threshold of 1.2 score for lift. And here that's where how we find. So in that if we buy mineral water, there is which has antecedent support of 20% and consequent support of 16%, that there's a high chance. So with the confidence of 22%, we can say that yeah, the people who buy mineral water are likely to buy chocolate, or people who buy spaghetti likely to buy mineral water. Also we can say that people who are buying milk are likely to buy chocolate and spaghetti, so and so on. Okay, so let's also check this as well. This is, for example, let's apply antecedents and length of antecedents and consequence. For example, length of the basket. So it's not necessarily antecedent as has to be one item. It can be multiple item as well. See, for example, here we can say, okay, let me explain this. Wait. Okay, so here you can say, Jay, for example, if a person buys ground beef and chocolate, high likely the person will also buy mineral water. Or if a person buys ground beef or milk, likely the person is likely to buy mineral water, right? So let's, this is the I'll be uploading the code in the GitHub link, and I'll be pasting the GitHub link right below. You can also, I can go through the code and clear your understanding, because this coding definitely it's about understanding, going through it thoroughly. So you can easily go through the go to my GitHub repository and check into the code. So finally, I have sorted the values for it, and to understand, to check all those consequence and antecedents which contains mineral, which does not contain mineral water. Because mineral, the reason behind this code is mineral water is obviously very popular item we have seen before. So let's just skip all those basket which has mineral water, and let's see other basket which does not contain mineral water, right? As a consequent, both as a consequent or antecedent. So this is where we come down to conclusion. So see, people who buy ground beef are likely to buy spaghetti. People who buys red wine likely to buy spaghetti. Uh, milk or chocolate, milk chocolate to likely to buy spaghetti. So here's the important thing: herb, people who are likely to, who buys herb and pepper. I think, I guess people in US love spaghetti a lot, or maybe the, I don't know the data set comes from which part of the state, but spaghetti seems to be quite a popular product as a consequent. Uh, so that'll be all, guys. So this is the recommendation algorithm to find out the relation between two multiple products, to come to a conclusion whether a particular product is purchased, uh, frequently purchased, given other products are purchased. And with this algorithm, you basically come down to understanding the popular or frequently purchased uh, basket of items. Thank you so much, guys. I hope you like my video. If you like my video, please hit that like button, and in order to support, please subscribe the channel. Thank you so much.